So you will send me the PDF, right?
I will send you the PDF today.
Yeah.
Okay. So we will start chapter 5, that is your periodic classification of elements. Periodic classification. Periodic classification of elements. Okay. So first we will talk about the periodic table. How the periodic table come into. Okay. The earliest periodic table that is come into progress. Okay. First, what is periodic table? I will check first what is periodic table. Do you know what is periodic table? Periodic table.
Yeah, in that there are all the elements written.
Okay, how it is written? Why it is called table? Why
Because it is written in table format, arranged format.
Yeah. The periodic, it is what is periodic table? It is the systematic arrangement of.
Systematically, yes.
It is the systematic arrangement of. Systematic arrangement of elements into groups and periods. Into groups and periods. It is a systematic arrangement of elements of groups and periods. So what is periodic table? Periodic table is a systematic arrangement into groups and groups and periods, and that is why it is called periodic table. Okay, got it?
Yeah. Okay.
The horizontal, what is groups? The vertical columns are known as groups. Columns are known as groups. The vertical columns are known as groups, whereas the horizontal rows are known as periods. Okay, very important. So I am just giving you the basic features first. So we will first discuss about the history, then we will come on this. Okay, so the vertical column are known as group, whereas horizontal rows are known as period. Okay, got it?
Yes.
There are 18 groups in the periodic table. There are 18 groups, and there are 7 rows.
Yeah.
And 7 rows, and there are 2 separate rows, separate rows also that are not included in the periodic table, that are known as actinide and lanthanide. Lanthanide, that is known as lanthanides and actinides. These are 2 separate actinoids. These are 2 separate rows that are not included actinoids in the periodic table. Okay.
Yeah. Okay.
Written?
Yes, sir. This is I'm still writing. Sir, I didn't understand the last part. 2 separate rows that are not included in the periodic table. What are those?
That is lanthanide, 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 and second is
Why? What is there in that?
There are some different properties there. That is why they are not included in the periodic table. I will
Okay.
tell you when we talk about this. Then I will tell you in detail. Okay. Okay.
Okay, done. No, no, just a second. I'm writing the answer. Okay, sir. I've done.
Okay. So I am just giving a glimpse of the periodic table, so that what I have written you can understand it. Okay.
Yeah.
Yes. Can you see the periodic table?
Yeah, yeah, I can see.
So here you can see what I have written. Just see it. Okay. This is your group. I have told you this is your the horizontal rows are known as group. No, sorry, horizontal rows are known as period. So it is this is your period. This is your first period, second period, third period, fourth period, fifth period, sixth period, seventh period. Okay. Okay. So these are periods. So 1, 2, 3, 4, 5, 6, 7. I have told you there are 7 periods, and I have told you there are how many groups are there? There are 8 groups are there. So this is one group, or 18 groups are there. 2 groups, 3 groups, 4 groups, 5 groups, 6 groups. So up to there 18 groups are there. Okay.
Yeah.
Then I have told you. So these are the main body of the periodic table. This is the main body of the periodic table, and there are two in below. There are two periods are there. This is known as lengthenite series. Lengthenite series, and this one is known as actinide series. Okay.
Yeah.
This is lengthenite series. So these are separated. These are separated from the main body of the periodic table. Okay. Okay.
Yeah.
And up till
Yes.
now, there are how many elements are there? Up till now, there are 118 elements discovered. There are how many elements are discovered? From 1 to 118 elements are there. So there are how many elements till now we have discovered? on this universe, that is 118 elements.
118. Okay.
Okay. So in this universe, there are 118 elements are present. Okay, got it?
Yeah. Yeah.
So this is what the periodic table looks like. Now we'll talk how the history of the periodic table. Okay.
Okay.
When we talk about the history of the periodic table, when you talk about the history of the periodic table, the first there is Dobner law of Fred. So first about the periodic table, first scientist who report that is Dobner. These are the important events that are going to take place in the history. Dobner's law of Fred. He tried to classify the elements. What does the Dobner law of Fred say that? It says that Dobner is a German chemist. It is a German chemist. Dobner is a German chemist. He is a German chemist, and he classified into elements into groups of three. And what does he do? He classified the elements.
Scientist, Darwin's.
German chemist.
Okay, he was a chemist.
Yeah. So what he does he classified. He classified the elements. He classified the elements into group of threes. Into group of three. So he first of all tried to classify elements, and he classified the elements into a group of threes and said that. So he said that these three elements have similar chemical properties. So when he classified the element, he said that these group of three elements have similar chemical properties, and he also stated that the atomic number of the middle element, the main points of this theory is the atomic mass of the middle element, was approximately equal to the mean of the atomic masses of the first and third atomic mass of first and third element. Okay. So what does the Dobner law of Pratt said that? He said that he classified the element into group of three, and he said that the chemical property of these three elements are similar, and he also said that the atomic mass of the middle element is equal to the sum of the atomic masses of the other two elements. Okay.
Yeah.
For example, write it. Written.
Just a second, I'm writing it.
You can also take a screenshot also. Written?
Just a second.
Okay.
Yeah, I didn't understand the last point.
I will go first just write it, and when I will give you example, you will get to know. Okay.
Okay. Yes, sir. Done.
Done.
Yes, sir. Yes, sir.
So, for example, if I say the first group he has made, that is the first triad is classified as elements. First triad is lithium, sodium, and potassium. Li for lithium, Na for sodium, and K is for potassium. So he said that the first group of elements is classified as lithium, sodium, potassium. They have similar chemical properties. Okay, they have
Yeah.
similar chemical properties. And he also said that so these three elements have different similar chemical and physical properties. And one of the most important thing is that it is said that the atomic mass of sodium is equal to the mean of the atomic mass of lithium and potassium. So we know that the potassium has atomic mass 7. Potassium has atomic mass 7, and potassium has atomic mass 39.
Okay.
So
Yeah.
we can find the atomic mass of sodium. That is atomic mass of sodium. That is A must be equal to A of sodium must be equal to atomic mass of lithium plus atomic mass of potassium divided by 2. So atomic mass of lithium is 7. Atomic mass of potassium is 39 upon 2. That is your 46 upon 2, or we can write 23. Yes. So atomic mass of sodium is 23, and it is equal to the arithmetic mean of the atomic mass of lithium and potassium. Got it?
Yeah.
Now you got the meaning of the second term.
Yes, sir.
Now you also classify another 3 element. That is second element, for example. That is chlorine. That is chlorine. Then your bromine. Then your iodine. Chlorine, bromine, and iodine. And we know chlorine is 35.5. Atomic mass of chlorine is 35.5. The atomic mass of iodine is 127. So atomic mass of bromine must be that arithmetic mean of, that is atomic mass of bromine must be equal to 35.5 plus 125 divided by 2. So 35.5 and 127 is 5, 12. So is 6, 162.5 divided by 2. So 162 was 8. So 162.5 divided by 2 when you divide 81.2. Yes, it is 81.2. 81.25. Or we can say 81.2. Okay.
Yeah. Okay. Now I got it. Okay. Can you give some one more example?
Basically, he has given these two. This is correct by these two elements also. Okay.
Okay. Okay. Fine. Yeah.
Okay.
Yeah.
Then now this law basically discarded. Why? Shortcomings on this law. Shortcomings. It is very important. In most of times, or
Yeah.
limitation. Shortcomings or discarding of this. Discarding of this. Why this law is discarded? Discarding of this law. Why this law is discarded? First, because because it was not possible. It was not possible. Is not possible to arrange arrange all the known elements because they are 118 elements. So it is impossible to arrange all the known elements into tribes. Okay. Okay. So that is why it is impossible. So it is these are the shortcomings of the law. Second, it is not applicable. It is not applicable to all the elements. To the all, it is not applicable to all the elements. All the elements of even the same chemical family. Of even the same chemical family means it is basically applied to 1 to 2 group of element like only two triads are discovered. It is not applicable to all the elements of even the same chemical family. Same chemical family. Okay.
Yeah.
Next, after the failure of this law, the next law is going to come, that Newland's law of Octave. Okay. Can I rub this?
You can repeat. Yes, you can repeat.
Then the next one is Newland's law of Octave. Newland's law of Octave.
Newton's law of
Octave.
Okay, I'm done.
So this law was discovered by John Alexander. Alexander, Raina, Newland. Okay. And what is the law says that? The law states that the elements were arranged in the order when the elements are arranged, when the elements are arranged
Again.
in order of increasing of the increasing atomic masses.
Atomic masses.
Yes. There was much similarity.
Okay.
Was much similarity. There was much similarity in the properties of every 8 elements. In the property of every 8 elements. Okay. So we say that when the elements are arranged in the increasing of the order of the atomic masses, then there is much similarity into the 8 elements. Okay.
Yeah.
This means that Newland called this, and Newland called this as repetition. Call this as law of octaves. Law of octaves. Law of octaves, because there is repetition of similar characteristic elements and it is similar to that, and it is similar to the musical scale.
Can you repeat the third point?
It is similar to the, okay, Newland called this as law of octaves. Okay?
Law of octaves.
Yes.
Okay.
Because there is a repetition of similar characteristic element.
Okay.
And this is similar to the musical scale, that is sa re ga ma pa dha ni sa. 8 notes. 1, 2, 3, 4, 5, 6, 7, and 8. Okay.
Yeah.
Okay, done.
I'm doing it. Okay, done. Yeah.
For example, if we talk about the example, if I arrange the lithium, this is the element, this is the table, this is the element, and this is the atomic number, atomic mass. So if we arrange them in the increasing order of the atomic masses, so like this is lithium, 7, then it is beryllium, this is 9, this is carbon, this is 12, this is nitrogen, this is your 14, then your oxygen, this is your 16, then your phosphorus, that is 19. This means that, so this is lithium, beryllium, oh, so there is boron also, boron.
Yeah.
Boron is your 11. So this is your first element, this is your second element, this is your third element, this is your fourth element, this is your fifth element, this is sixth element, this is sixth element, this is seventh element, and the eighth element, that is eighth element. When you write the eighth element, so this is your eighth element.
Yeah.
So this is the eighth element, and this is your element, and this is your atomic mass. Atomic mass, this eighth element is your sodium, that is 23. And when we found that the properties of lithium and properties of sodium are same, because this is the eighth element. If it's contrary, this is the properties of first element is similar to that of eighth element. Okay.
Yeah.
That by itself. Then again, if you arrange them, then next is your sodium, then it's your magnesium, 24, then your magnesium, then your aluminum, that is 27, then is your silicon, that is 28, then is your 12th is your phosphorus, that is your 40 or 31, then your 14th your sulfur, that is your 32, then your chlorine, the 50, so 8, 9, 10, 11, 12, 13, 14, and 15. 14 is your, so 9, 11, 8, 9, 10, 11, 12, 13, 14. Okay, so sulfur, then is your chlorine. Chlorine is your 35.5. So now you can, every 8th element is so beryllium has similar properties to that of magnesium. Then boron has similar properties to that of aluminum. Carbon has similar to that of silicon. Nitrogen has similar properties to that of phosphorus. Then your oxygen has similar properties of sulfur, and chlorine has similar properties to that of chlorine. Every 8th element is that of repetition of the first element. Okay. Then next is your, this is your 15, then 16.
Yeah.
16 is your potassium. Potassium, that is your 39. Then next is your calcium, 17 is your calcium. That is your 40. So you can see every 8th element is the repetition of the property of the first element. Okay. So this is your 8. So this lithium is first. This is your 8. So it is similar to that of lithium. Then this is your 8. Then sodium. Sodium is similar to that of potassium. It is 8. Okay. So we can say that lithium, sodium, and potassium has similar properties. Like with beryllium and magnesium has similar properties. Boron and your aluminum has similar properties. Carbon and silicon has similar properties. And your nitrogen and phosphorus has similar properties. Oxygen and sulfur has similar properties. And chlorine has similar properties. Likewise, this manganese is similar to that of beryllium. Aluminum is similar to that of boron. silicon is okay. These are so, and likewise potassium is similar to that of lithium, and if calcium is similar to that of magnesium. Got it? So every eighth element is the representative of the first element when we arrange them in the increasing order of the atomic mass. Correct?
Yeah.
Now
Correct.
this law also fails. This law also fails. Why fail? Because this law is drawbacks of this law. Drawbacks of this law. One of the major drawbacks of law. This law is in majority of cases it is correct, but this law is applicable to. This law is applicable. Only to element up to element up to calcium, which is for T down. So this law is applicable only correctly up to calcium. Because after calcium, eighth law is not applicable. Okay. First of the major drawback of this property is that this law is only applicable to the element which belongs to property up to calcium, which has element up to calcium. Okay. After that, it does not follow the eighth law loop. Okay. Then second, that several new properties. Yes.
Okay, you can tell what we say.
Yes. Second is several new properties are not described by law of Octave. बहुत सी प्रॉपर्टी लॉ ऑफ ऑक्टेव नहीं डिसाइड कर पा रही. तो दो इंपॉर्टेंट प्रॉपर्टीज क्या हुई जो जिसके लिए ड्रॉबैक से पहला द लॉ ऑफ ऑक्टेव ओनली applicable up to calcium at element and higher element have no value for this higher element cannot be described that, and second is that several important properties are not found out by law of Octave. Okay.
Yeah.
Next is, so after these two properties, the one of the major success has been given by Mendeleev. He classified many more elements on the basis of their atomic masses. The next law is Mendeleev's periodic table. You know Mendeleev's periodic table. Mendeleev's periodic table. And what does the Mendeleev's periodic table says that? It says that the very important property. He decides the major break. The property of elements are periodic function of their atomic masses. So he says that there is a repetition in the periodic properties when he arranges the element in the increasing order of the atomic masses. Okay. So it means that it means to say that when elements are arranged in increasing atomic masses, then properties of element are repeated after regular period. Got it?
Yeah.
So very important. He described majority of the he classified majority of the elements up to that time.
Yeah.
So first basic of this periodic classification is the basis of his. Okay, this we will share class tomorrow. Okay, the basis of the periodic classification. Okay, so up to this you are clear. Up to this you are clear.
Yes, I understood.
Yeah.
So, but then, sir, in the after Mendeleev's periodic table, then we should do the modern periodic table also, right?
Yes, this is the main. This is discarded. Up to Mendeleev's periodic table, it is discarded. Now we are not studying up to the Mendeleev. We are not studying Mendeleev's periodic table because it is wrong.
Yeah.
Okay. So nowadays we are only following modern law of periodic table. So this is how the periodic table come into existence. The presence form of periodic table. How can we are talking about that? This is about history of the periodic table. Okay.
Okay. Fine. Yes, sir.
The main periodic table we have to study that is your modern periodic table. Okay.
Okay. Okay. Yes, sir. Okay.
Bye. So we will take class tomorrow at the same time. Okay.
Okay. Thank you, sir. Bye, sir. Bye. Bye.